All right, so we're going to look at systems of linear equations. And the word systems, when we're talking about systems, that typically means, or it always means, that there's more than one equation we're trying to solve. We want to know a solution that fits all of the equations in that system. And so we're looking specifically at linear equations, so equations that make lines. And to solve those, we are going to look at the strategy of graphing. So the solution of a system is the point where these lines intersect. And so your first step is to graph the lines. So I like to use different colors. So I'm going to use purple and blue. The first one I'm going to do is purple. So to graph this, I want to first graph the y-intercept at +1. And then my slope is 2. So that means I'm going to rise 2, run 1. And so I just do that a couple of times in both directions, and then use a straight edge to connect those points. It's really important that you line these up very well because we are looking at where these lines are going to cross. And so if we don't line them up good, that's for some reason not great. If we don't line them up well, then they won't cross at the correct point. All right, so the second one, I have a +3 as my y-intercept. And then my slope is 1. So that means rise 1, run 1, 1 over 1. So I'm going to go up 1, over 1, up 1, over 1. And that actually crosses right there. So that's great. I can see that those points are the same, even though my line's not perfectly on there. That was one of the points that I sketched out. So again, this purple line, for some reason, I didn't get it exactly where I wanted, but I can tell that these two lines are intended to cross right here. That was one of the purple dots I went up to over 1. This point is at 2, 1, 2, 3, 4, 5. So the solution is 0.25. And I want to verify the solution by plugging it in to both of the equations. So this is my x number, this is my y coordinate. So y is 5 and x is 2. And I can visually check that. I know that 2 times 2 is 4, and when I add 4 plus 1, I get 5. And so it shows that that is a solution for the first equation. I'm going to check it for the second one. Again, I'm going to plug in 2, 5 for y equals x plus 3. So y is 5, x is 2. And of course, 2 plus 3 is 5. So the 0.25 is indeed the solution of this system of equations. So let's look at another one. In this one, I can see that the second equation is not written in slope-intercept form, so I'll have to do a little work on that. I'll go ahead and graph my first line. So this is my y-intercept at -1. My slope is -1/2, so that means it's going to be decreasing, going in this direction. And so I'm going to go down 1 over 2 and up 1 over 2. So again, I put several points just to really make sure I line that up well. And I'm going to connect those points. See if I can do a better job this time. That looks better. All right, and then my second equation is not in slope-intercept form. So in order to get y by itself so that it is in slope-intercept form, I need to divide everything by 2. So when I divide by 2 here, I get 2 on top and bottom. That's 1. 1 times y is y. Over here, I have -1x divided by 2 is -1/2 x. And then -2 divided by 2 is -1. So my y-intercept here is -1. Oh, that's actually where they touch. Let's see what happens next. My slope is -1/2. So going this way, decreasing down 1 over 2. And what you notice here is that these points exactly line up because these equations are exact matches. And so I can't quite see this great, but these overlap. These two equations represent the same points on this line. So when the two equations represent the same line or the same set of points, then we say that there are infinitely many solutions. I'm not sure that I spelled infinitely correct, but this is not all real numbers. It is all the numbers along this line. And so this point, which is +2, -2, this point, which is 0, -1, this point, which is -2, 0, every point in between there and beyond will work in both this equation on the top as well as this equation here on the bottom. All right, so let's do one final one. In this final set of equations, we have y equals -3x plus 2. So my y-intercept is +2. This is negative, so again, it's going to decrease, and that slope is -3/1. So down 3/1, down 3/1. I'm actually going to go up 3/1 as well to get another point on there. And then I'm carefully going to put these on my graph. So there's my first equation. And then my second equation is y equals -3x. So that means that my y-intercept is 0. So it's right here. And then my slope is -3/1. Notice they have the same slope. So I'm going to go down 3/1, down 3/1. I'm also going to go up 3/1, up 3/1. And I'm going to connect those very carefully. And so I'm looking at the point, looking for the point where they cross, because the point where they cross is the solution. But I want you to notice that these lines do not cross. They also don't get any closer to each other or any further apart. So these are actually parallel lines. And parallel lines never cross. So that means that there is no solution. There is not any single ordered pair that we could plug in and make these two both have, or there's not a single ordered pair that would work to make both of these true statements because they never cross.